Hello everyone, welcome to the last session of this week. In this session, we will talk about another case study, the Newton Raphson Method. The Newton Raphson Method is used to find the roots of a polynomial. So in this case study, you will learn two things. First, we use the MATLAB loops in the iterative method. This is the Newton Raphson method, and you will learn the method itself. It's very useful for you to find the roots of a polynomial, right? So let's see what is the problem. So here I draw a polynomial in a certain area. So x from -3 to +1. So this is a polynomial. So what is a polynomial? Is here. Is x with the power of 4 plus 4, x with the power of 3, and blah, blah, blah. So this is a polynomial in this region. So the root of a polynomial are those if we consider the polynomial is fx, the root is x, the value of x, 1, fx is 0. So we can see the red dots. So from -3 to +1, this polynomial have four roots. So in them, the value is 0. So how can the Newton Raphson method find that? So the Newton Raphson method follows an iterative process. So each time we consider an x, and this x can be anything, and we follow this formula to generate the x n minus n plus 1 in the next iteration. So we can see xn, the current iteration n, x is this value, but x minus the fx divide the derivative of x at xn. So this is the formula. So this needs some calculus. If you don't know it, no problem. We will calculate it for you in the future slides. Right. So iteratively, we do this process. We improve the x value little by little, and until the fx is 0. So this is the process. So how to program it? The question is here. So clearly, this is an iterative process, so we need a loop, right? But using for loop, this is not easy because we don't know how many times it will use for the fx to be smaller, and equals to 0, right? So we need to use a while loop, right? So this is a program that we can get. So we first provide x0. This is our initial guess, right? Then we go to what? While fxn larger than delta. So this delta is an error tolerance. So maybe eventually the fx really cannot exactly equal to 0. But if it's small enough, we also accept it to avoid a dead loop, right? And in the loop, we update the x value based on this formula. Then we end this while loop. We'll iteratively write until we get the answer, right? So let's summarize the Newton Raphson method. So this is an algorithm for approximating the root. So the root is the points where the function value is 0 for a differentiable function. So for example, this. So we will continue to improve the x value until we eventually get the root. So we can see here. So here I provide the polynomial is here. So the derivative, we can calculate it. So this is a derivative. So we can see it's here. Now we have an initial guess. We randomly to a point, 0.2. And we can find there will be a root here, right? So it's near to it. We can see using 0.2, how many steps, we can get to the root. Right. Now we need to write the program. So to write this program, let's first write two functions. We first write the fx function, then the derivative of fx function. So they are here, right? The function is y equals to fx, is this function. Then the derivative dy dx, we put it as a f prime x. So this one, we write this formula in. So now we know the function, we know the derivative, we can start the loop, right? So now we first give an initial guess. x0 equals to 0.2. I calculate its fx value. I calculate is a derivative. We call it grad. Right? So it's here. Then we can start the loop. The loop is what? We get the tolerance, this delta, 0.001. We initial x as x0. Then we start the loop. Well, fx is still larger than the tolerance. We do this one. We calculate the fx value. We calculate the f prime value. We use the formula to update x. And this x go to the next iteration. It will come here until this condition is no longer met. Then the while loop stopped. So the root is found. So if you run this program, you will find the x is this one, and you can see the y value is with e with a power of -4. So it's very near 0. So the true value is 0.10408. This is 10409. So it's very near. Almost we get the root. Right. So we have used the Newton Raphson method and the while loop to finish this task. So that's all for this session. So before you go to the quiz and the assignment, right? So there are also an unmarked exercise. You can see the slides there. Okay, thank you very much. Then we will see you the next week. Bye-bye.